of Enigma, a planet that evolves daily, and yet the small changes cannot be seen with the naked eye. What we witness on the surface are the unforeseen circumstances that manifest from the deep recesses of the Earth's interior. What we do know is that everything is connected. A shift in the Earth's crust on one side of the world can lead to a massive disaster on the opposite end. What can we do to try to prevent these tragedies? On any given day, there are at least 10 volcanoes ejecting ash or lava and an average of 50 earthquakes occurring around the world. With so much activity, scientists are working diligently in attempting to predict the next cataclysm and preferably being able to protect the citizens of our planet. This is a map of all the major plate boundaries. The green represents convergent boundaries, where plates are colliding against each other. The blue represents transform boundaries, where plates are sliding against each other. The red represents divergent boundaries, where plates are moving away from each other. If you look closely at the green line, you will see teeth marks. What that means is that the plate is moving underneath another plate. For example, the Pacific plate is being pushed underneath the Eurasian plate. The Nazca plate is being pushed underneath the South American plate. And the African plate is being pushed underneath the Eurasian plate. Subduction zone. The area on a convergent boundary where one plate collides with another plate, but is pushed beneath the other plate due to the overriding plate being denser. Convergent boundary. Two plate boundaries colliding towards each other. For example, the Pacific plate and Eurasian plate, Nazca plate and South American plate, Cocos plate and Caribbean plate. These plates are pushing against each other. Divergent boundary. Two plate boundaries moving away from each other. Examples are the African plate and South American plate, Eurasian plate and North American plate, the African plate and Antarctic plate. These plates are separating from each other. Transform boundary. Two plate boundaries sliding against each other. Examples are the San Andreas Fault, the Alpine Fault, New Zealand, Queen Charlotte Island Fault in Canada, the North Anatolian Fault in Turkey, and the Dead Sea Rift in the Middle East. At this point, you've learned of the three types of plate boundaries: convergent, divergent, and transform. Now we're going to search for earthquakes associated with those types of boundaries. What you're going to do is go to this website, earthquake.usgs.gov/earthquakes/search/. In this site, you can search for earthquakes that has happened within the past 30 days, if not longer. Scroll down, and these fields can be manipulated to widen or narrow your search. We'll just stick with these parameters, for example, and scroll down to the bottom and click on search. It brings you to this area where there's a map, and all these yellow and orange dots represent the earthquakes that's occurred within the last 7 days. And if you can see with these red lines, those are the plate boundaries. And if you can refer back to this map, which should be a handout in front of you, then you can associate the earthquakes with those types of plate boundaries. So what you're going to do, you can scroll or zoom in, and when you refer to your map, you'll know that this is a convergent boundary, this right here is a transform boundary, and the divergent boundaries right here. So you can see there's earthquakes associated with those plate boundaries. Now what you're going to do with that information is, for each one, find an earthquake and then gather the information. So you click on one of these, and this will pop up on the side on the left, and click on it, and it'll take you to this page. And this page right here will give you information of what I need, which will be on this page right here. It's already pre-filled with information that I've located myself, so I'll show you that example, which is this one. So it's going to ask you for the location, which is this portion, the magnitude, which is this right here, 5.5 magnitude, the date and the time, and then you convert that to local time, and I've attached a chart for you to convert that. The depth of the hypocenter, and then the intensity level if it's there. So some earthquakes will have that information, some won't. It just depends on where that location is. If it's in the middle of the ocean, most likely there's no one that's going to feel that. And then responses. These are the number of people that responded in a matter of time frame, right here at the bottom in minutes. So that's located in the Did You Feel It report. So this is the page, again, of what I've searched out. And this happened on Saturday. If you look at the calendar, 12/1, that was a Saturday. 23:55. Convert that to our time. That is, I believe, -6, it's 5. Let me refer back. 5:55 p.m., yes. And then it was the hypocenter, which is how deep the earthquake was, the real location of where it started. It was 10 kilometers below the surface level. On the surface is where the epicenter is. This is the number of people that reported something to the USGS website. And scroll below, did you feel it? The intensity level was 7. And let's scroll down. Intensity level varies from 1 to 10 plus, from not feeling anything and it's weak to extreme, very heavy damage. So, on this form, you'll fill out the location, the magnitude, the depth, the intensity level if it's provided, the date and time, and convert it to our local time of when the earthquake occurred. And then, right here, you put in what type of plate setting it was on. So, for that one, it was located here, where the epicenter is, and this is the Nazca plate and the South American plate. And as I said earlier, the Nazca plate is subducting underneath the South American plate. So I wrote down Nazca plate is subducting under the South American plate, and the plate boundary is convergent. And then for the effects, that's where other websites come in handy. Usually news journals or news articles, on websites, and what you do is you Google the earthquake. The more specific, then the more narrow your search can be, because there's tons of earthquakes occurring at very close proximity, so you kind of want to narrow that down. And just look for articles that are related to that would report if people were hurt or if there was damage to buildings.
For this one, not a lot has been reported, either because not a lot was damaged or because it was so recent. But what I did like was going to earthquakenewstoday.com, and this one right here reports pretty much the same thing as usgs.gov, except it's a little bit more elaborate. But what I liked about it was it reported that a tsunami warning has not been issued because earthquakes do cause more damage at some points that's not just at the actual location, but it can spread out across the oceans. So I would type that down in my effects. So that is the assignment. Just filling out location, magnitude, depth, intensity if provided, date and time of the earthquake. Here is a conversion table of times, the type of plate setting it's on, indicate where on the map is the epicenter, and any effects, damage, people that were hurt, indicated in the effects. And so that is the assignment. And any questions, just come see me.